I will start with today's first talk, and I will try to keep it on time. So, I think this works. Yeah. It's this. All right, so the wobble in our projector is pretty cool, given that this entire presentation was created this morning by ChatGPT with no help from me at all. In fact, the only thing I did was I added the synthesized by ChatGPT to this slide. Now, this is really good, not because ChatGPT is amazing, but because the documentation we've been putting into Fabrica over and over again was enough for it to be able to do this talk for us, to do this. The effort that we spend to make documentation readable, accessible, make sure it's all up to date, that leads to people being better able to use tools to understand it. We've got a website for Fabrica. We've got the Git repositories. We've got lots of use cases. And so as I walk through this, keep in mind, there's nothing in here that's been hallucinated. I did check that. And everything came right out of our documentation. So if there are places where you want more information, the documentation probably has it. Okay, so code generation for coding standards. Why did we build Fabrica, and what do we want to use it for? So I'll start with one of the things that I dislike most about being part of an open source community, and that is meetings where we discuss standards. I have been in many of them. I understand that it is valuable to have a bunch of people agree that we are going to do things one way and we're not going to do things 10 ways. That's necessary. However, every time we make a decision, like we should use pagination in this particular way, or all of our IDs should be focused in one way or another, right? We write that down, and then we expect every new developer who comes to the project to read all of these things before they start writing any code. And if they fail to read all of these things before they start writing code, then their first PR is going to be littered with, didn't you know we have a standard for this? Didn't you know we have a standard for this? Here's a link to our standards. Please join our standards, right? So I said, well, what if instead of doing that, we wrote a framework that makes it really, really easy for someone to just handle all of the standards with automation, through templates, so they can focus on the thing that they really wanted to do in the first place, which is contribute code that does something, right? So Fabrica was my attempt at that through Go templating, which Go templating works really well for templating out more Go code. And the more I looked at the areas where we wanted to standardize, the more I found it was really that boilerplate that surrounds business logic that we don't really want people to think about anyway. And as I moved more of the services I was already working on into Fabrica, I realized we were getting to the point where it was like 90% boilerplate and like 10% the stuff I wanted. So a few things that make this possible are conventions around the shared API envelope. Kubernetes did this really well. Kubernetes says, here's the kind of thing you have, here's where to learn more about it, here's how you identify an ID, here's how you separate the things that are editable from the things that are not editable, all of those. So we just adopted that. And in fact, we went through 3 or 4 iterations on what this should look like. Shared lifecycle behaviors. So most of the APIs start from a CRUD API, and then you add additional things. So create, update, read, delete. Yeah. Those things are known quantities. For every individual resource, like you can write those things in your sleep. So this thing just writes it for you. It then means you want validation hooks, right? Like I want to make sure that our X names fit the right pattern. I want to make sure that no one is putting emojis in my host name file because that's going to be really annoying, right? Like those kinds of things are really easy to add. And so we put pluggable validation into this as well. We hooked up status handling. We hooked up middleware, all of these kinds of things kind of in the template. And then it also creates it in a way that is easy for you to start playing with the service immediately. You don't have to have a database. You don't have to have anything else. It can store all of your resources in flat files on disk. So you can go and look at them and look at the history of them with your favorite editor, and then understand if things are being modified the way that you want. Some of the other pieces that we added to OpenShami include like state machines that can be hooked up to external things or internal things. So as you mutate the state of an object, it emits a I changed event, and that I changed event is standard across anything else that uses Fabrica. So you start just by creating a Go struct, and I might have some issue with the way ChatGPT did this, but it is readable. The API version, the kind, the metadata, these look familiar if you're familiar with Kubernetes. If you're not, you don't have to be. They're fairly self-explanatory. And then a spec that says, here's the things that define my object. Because you've got in there all of these struct tags, and if you're not a Go programmer, a struct tag is kind of like documentation, which allows you to describe the behavior of the field. So this has the product status as it is a status field, and it will be omitted if it is empty, and will be represented in JSON with this particular format. So that's kind of over there in the bottom. So when the Fabrica generator runs, it creates a bunch of these files that all have underscore generated in them. And when you see an underscore generated file, you don't touch it, because Fabrica will regenerate that for you. There's other files in there that it will generate that are completely editable by anyone. You should check them into Git. You should do all of these things because you want to be able to control the business logic of the microservice that you're building. As we were doing the template generation, it became really clear that if we could do a server, we could do a client. So a client library and then a CLI, all using the same struct. You get them all for free. Makes it really easy to prototype a new thing, and then, as we found, continue on. So this has been pretty great. So I think with the first service that I started working with, it was about 100 lines that I wrote, and there was about 1,000 lines to 2,000 lines of templated code. All of it readable, all of it easy to compile. I have to focus on the roughly 100 lines, and then Fabrica takes care of the rest. The first thing you do initially is the project. Fabrica keeps a file called fabrica.yaml that describes all of the things about how Fabrica ran, what version was used, the things that Fabrica needs to know to do its job well. There's an apis.yaml, which defines which APIs you're actually exporting. So if you want to build something and then you want to comment something out, that's where you go to comment it out. And then there's a bunch of stuff that it creates. All of the things in there, and actually a bit more as well. Pluggable storage, pluggable open API standards, things like that. You can start something like this in about 10 minutes and have a working prototype that you can start playing with. By the end of like the third day, you will probably have regenerated with Fabrica, because you can rerun Fabrica to regenerate all of these generated files, because no human should touch those, and Fabrica will do all of that on its own. So when we added customizable middleware to Fabrica, we just regenerated existing services, and we didn't have to change any of the human-edited code. We just threw the middleware in there. It does emphasize the CRUD stuff, although with the work that we were talking about yesterday with SMD2 and a lot of the services we already have, we create custom handlers, we create custom workflows, because we want to be support the legacy APIs that we're inheriting from previous versions of OpenShami. Makes it easy, but that is still work that you have to do yourself, because the legacy APIs are not following any standards at all, and so each of those have a behavior that we have to kind of learn first. The quick start is actually in the documentation. It'll walk you through this whole thing. I'm not going to do that for you, but it's there. All right. So a little bit more about the structure of that that object, the get struct or the go struct that is going to be used here. The spec is this is the user authored schema. What do I want this thing to be? This is where your business fields live. This is also where you say, I would like the state to look like this, and then it proceeds. The metadata is the envelope. The envelope is what makes all of the metadata, all of the Fabrica stuff able to do most of the templating, because it knows that there will always be an API version, a name, a UID. There will always be labels and annotations. And so then generic filtering works based on those sorts of things that you can then build additional filtering based on your business logic if needed. The observed state is the status. And so I can't change the status of a like powered on or powered off. I can request that a change happen by indicating that I would like to see a power off happen. I will find out if that has happened when I query the resource and find out what is the status of that. So observed state versus desired state in the same resource, all of this is basically coming for free as part of the Fabrica contract. By putting in things like annotations, timestamps, like in the standard or in the framework here, rather than having people choose them, we can apply the same rules everywhere. So your timestamp is always going to be UTC, right? Your UIDs are always going to be constructed the same way. So these generated guardrails, they're not just useful for our developers. Like as we start saying we want storage to look one way, we want events to look another way, we want evolution to look another way, because it does anticipate that every API is going to go through a versioning cycle, and that we are going to want to emit events as things happen, and we do not want to put secrets into those events. These are the kinds of things that AI gets wrong when you just vibe code a new thing. I don't know if you were here yesterday, you heard me talking about how there's a developer in Europe who did what he calls a clean room implementation of OpenShammy by looking at all of our documentation, but none of our code, and then teaching Claude to make it all work. It passes the initial tests, but there's a bunch of places where it is making assumptions that are not true, and it's in these sorts of areas, like very naive storage, very, very naive event system, no capability for evolution or API versioning. Now, we could write more documents. And as we can see, like AI wrote all of this. If we wrote more documents, AI could do more of building the clean room implementations. However, if you give the AI the Fabrica toolkit, teach it how to use that, which is very easy, then the AI is going to get you there faster, use fewer tokens, and you're going to be sure that everything is standard and you're not subject to some of the AI slop problems that we've seen from the other talks that we've seen this week. One last thing that I want to highlight in here, reconciliation. So if you are aware of how Kubernetes does its reconciliation, or if you saw my talk yesterday about the observe, the loop that you want to go through to reconcile a resource, that is where we talk about our state machine. And if you request a change and it cannot be completed, understanding how to report that back, that's all part of Fabrica, and that's pluggable. So if you want to do a built-in, like in-process Go template for this, that works. If, on the other hand, you want to externalize your state machine with a library like Temporal that does like more cloudy things, all of that works out of the box as well, because we've got a library that handles all of that. This reconciliation has been a place that I found very useful as we are trying to look at long-running, evolving resources. Like, how long does a power state take? How long does a boot take? We may get the boot cycle where we tell it to power on, but it's not the power system that's going to tell us when it has reached the standard run level. Across a microservices infrastructure, we need something that can watch the event that's coming in about power state, and then also watch the event that's coming in about I have reached final cloud init. And all of that's possible if you have standardized events and you have a pluggable reconciliation system. So as we've mentioned, you register the resources, you generate the artifacts, you do not edit the generated files, and then you add your files as needed. These coding standards are now encoded not in convention or documentation, although they are well documented, we don't expect you to read that documentation. We expect you to encounter it as you use Fabrica, and you look at, say, well, what if I want my timestamp to be in my local time? And Fabrica will tell you, no, don't do that. We want you to be like everyone else. So it's a strong fit for our resource APIs. We have looked at some of the graph APIs. We've looked at streaming APIs. We haven't extended Fabrica for those, mostly because we don't have a whole lot of those in OpenShami yet, and we don't have standards around them that we want to encode. So I don't want to push people towards things that we haven't really experienced, we don't have a ton of experience with. There are places where you won't benefit. The built-in versioning is really useful, but if you need a quick prototype, you can turn it off, right? But if you have something that you want to be sustained for forever, this is the kind of thing to use. I don't think I talked enough about cloud events. Anyone familiar with OTel or cloud events? Okay. So a lot of the tools that we have used previously, and this was a complaint that we had when we started the OpenShami project, a lot of the tools, they emit logs. And syslog is real chatty. And you may be able to say, like, I only want warnings, or I only want like info, whatever, right? But you're still getting a really chatty. So one of the things we've learned in cloud is that if you have semi-structured events that are being emitted at regular intervals in the way that you expect, you don't need the logs the same way, because you're now seeing each of these resources has gone through one change of their state machine, and who did it, why did they do it, which instance was happening, was it going through, like those kinds of things, who authorized this behavior. If you put all of those semi-structured things in, you can still put a message in at the end that says, oh, and by the way, you know, I saw a Python error come through. But you have all sorts of control over that. When you put that semi-structured stuff together, now you've got something that is suitable for most databases, that is suitable for lots of parsing. And one of the items that I'm hoping we're going to be demoing in the next few weeks at a TSC meeting or office hours is, well, if you then stream all of those into a data warehouse structure, you can do what's called engine-less databases to do huge amounts of query with very little CPU. And we're looking forward to that as kind of the first troubleshooting piece that pulls together all of the OpenShami microservices, because they are all emitting cloud events, and all of those cloud events have similar structures. This would be possible if we had to teach everybody how to do this. It's much, much easier if we have Fabrica say, here's the default. You can improve it, but the bar is now set at a fairly high level. I suppose this just covers what we've done already, but if you are interested in doing this, follow through with standardize your resource contract, treat the templates as your governance. Don't, focus more on humans having to read it. The generated code must be separated from the user code, so that you can regenerate those generated files over and over again and never fear losing things. The storage and lifecycle stage, start out with your flat files. Don't get overly concerned with the SQL that you're going to need until you have realized that you have your data model correct and it's useful to you. And then lead into the evolution of features. So another big piece of why we created this is because we know that the APIs are going to evolve over time. We need a way of moving from API v1 to API v2 to API v3 without breaking everybody else. And so API evolution had to be a first-class citizen. All right. That was my 20 minutes. I will take questions, but if you want to take a look, go to the Fabrica GitHub. That's the best place to start. github.com/openshami/Fabrica. Go through the guides, go through the examples, try something out, or try to come and join one of the existing microservices that is already using Fabrica and work with us on it. I'll take questions if anyone has any. Yeah, and we Well, I guess I'll repeat the questions so we don't have to pass the mic around as much.
Okay. So my first question is for the generated code. Are there tests also generated for that?
That's a great question. Yes, it does generate tests. There's obviously not tests around the business logic that are automatically generated because Fabrica doesn't know about those. But Fabrica does include tests for the standardized behavior to confirm that the scaffolding is all working correctly.
So, and for the business logic components that you write yourself, do you bleed into the underlying technologies that you use, or do you establish interfaces that are Fabrica interfaces? So, for example, if you wanted to change the underlying HTTP kind of framework that you're using.
So the question is, how much is the Fabrica choices bleed through, and how much are provided via interfaces? So Fabrica does assume Chi as the HTTP handler. That's probably something we could change, but because so much of it is we need to generate we need a template to generate from, and so those templates assume Chi, but the handlers themselves are just HTTP. What are they called? The standard Go HTTP handler format. So if you want to generate it to do user logic next to it, that launched a completely different, in your main, launched a completely different HTTP framework, it would probably work.
HTTP framework is probably a bad example, but I'm just wondering, like,
Yeah.
For example, like we've changed the reason it's used
Yeah.
in the past.
Yeah.
And so if that's exposed, then, and we make a decision that we want to move to something else, then all your business logic is going to be affected.
So if we were to change routers, and so the question, the follow-up is basically, if we were going to change routers, would we have to change business logic? And the answer is probably no, because that all still fits within the templated code. So if we made the change, we would regenerate all the templates, and all of the underscore generated code would change, and it would fix that for you. You might have to do a little bit of plumbing work to like reattach to the right places in the code, but I think for the most part you could make those sorts of changes. The other places where we have pluggability, pluggable storage engines through a library called Ent, which is common across the Go ecosystem, which means you're not learning the Fabrica interface, you're learning the Ent interface, which you can easily Google, and they will work on it, and they do all of the SQL optimizations. The same thing is true for our authentication authorization. We're using CASBIN for authorization policy, because that's another thing you can Google. It is embeddable in what we're doing. It does then, if we want, scale out to be more of a cloud service if we want it. If there is a place where there is a third-party library that we don't maintain, that we can use instead of our own generated code, I prefer it. And so if there's a place here where you go through the code and you're like, you know what, I would like to be able to switch out the router, I'm interested to figure out how we could do that. Router may be a bad example, but like anything else. Other questions? Yeah.
So are you, I haven't looked at some of these services, but are you actually checking in the generated code into version control? Yeah.
I'm checking, yeah. Rather than regenerating on the fly, I'm checking it in. And that was so the question was, are we checking the generated code into the services? And the answer is yes. I looked at regenerating it on the fly as part of the build process for every resource. But then I realized that we were losing a lot out of that, because you can't read where things are happening to then understand where to attach your additional business logic. Yeah, this makes it very transparent. Yeah. All right. Yeah.
Is there a separate error handling done in the generated code? Or?
Is error handling in the generated code? So yeah, actually, some, probably not. Well, I'm sure there's areas we could improve, but the HTTP handlers all support most of the error statuses that we have ever seen in our work. So the client will get a rich error if something goes wrong, which is also really valuable. And yeah, the other error checking that is happening is at generation time if your structs don't look right, the generator will say, here's the problem with your struct, here's how you can fix it, where it kind of knows. But so we have error handling in both of those places. If there's more we need, please, file a bug report. I'm happy to add it. We covered the errors that I tend to make pretty often. I'm not sure we covered the errors that you would make, but that's part of open source. All right, anything else? I think Ben's going to talk about actually using Fabrica to generate the fruit service, but yeah.
So I know we're using Fabrica for the fruit tracker.
Right.
Do we see Fabrica becoming an underlying API generation tool for the other microservices in the OpenShimming project? And if so, how do we plan to roll that?
Great question. Okay, so we have Fabrica. So you're asking about Fabrica across the whole of the OpenShimming project. So we have Fabrica generated alternatives to BSS and the Cloud Init service, and the fruit tracker starts with it. We're working on SMD2 and working on a firmware service. So one of the concerns that we've had is everything needs to be backwards compatible. And so when I did the boot service, Fabrica, to prove that it would work, I made sure that even though the Fabrica endpoints were going to do the new Fabrica cool stuff, all of the existing BSS clients should work just fine with this. Now, if you want the new functionality, you have to use the new API, but the old API has to always be there, or at least as long as we want to support it. And that's probably going to be a while. Okay. Yeah.
I have a related question. So, as someone who's worked on PCS, for example, what's the migration strategy?
So what would the migration strategy be for PCS? PCS is an interesting use case, and probably one of the more challenging ones to get to, because it does have multiple threads that are running at the same time doing multiple things. And when we worked with SMD, we pulled out the discovery thread because it was making it hard to evolve SMD. My guess is we would have to do the same thing with PCS, and then figuring out where that goes, and this gets into the BMC questions we were having. But the first thing that I would do to evolve a service is look at what its main resource or resources are, and encode those as Fabrica, and get the CRUD stuff working. And if the CRUD stuff is working, then you can add the additional stuff. But until you feel comfortable that the CRUD stuff is working well, there's challenges. Does that make sense?
Yeah. Maybe put that more.
I'm happy to. Yeah. All right. Any other questions about Fabrica before we hand off to Ben?